In section 1.5, we are going to be talking about angle pair relationships and how to solve problems with them. There are 5 specific angle pairs that we are going to talk about. The first 2 I want to talk about are supplementary and complementary angles. Now remember, I'm talking about pairs of angles. So all of these are going to be 2 angles and 2 angles only. So not 1, not 3, 2. So for supplementary angles are angles that total 180 degrees. So you just have to have 2 angles. When you add them together, they equal 180 degrees. So that's the formula here. Piece plus piece equals 180. So plugging in the angles, whether they're actual numbers like I have here. So if you wanted, you could do 120 plus 60. Or you're going to get into expressions where there's actually some algebra to solve there. So supplementary angles, they can be touching like this, or they can be apart. They don't have to be touching, and we'll learn what touching angles are called in a little bit. But they could be touching or not touching, but they have to total 180. Where complementary angles need to total 90. Okay, so 2 angles that total 180 for supplementary, 90 for complementary. So make sure you study the difference between those, and you know when you see the word supplementary, it's 180, complementary, it's 90. Again, complementary can be angles that are touching, or they don't have to be touching, but they do total 90 degrees together. So like I said, touching angles, I said I'd tell you what those are. Those are called adjacent angles. So angles that share a common vertex. Okay, so they touch at the same point right there. So not one moved up like this, but they start at the same point. They share a vertex, and they actually share this middle ray here. So there isn't any space between them. So it's not like this, where they just share a common vertex, but there's middle here where there's a blank spot of the angle. So they share a common ray, no space in between, and are touching. That's called adjacent angles. So if I were to kind of color this in, so here's angle A, right, taking up all of this space. And then here's angle B taking up all of this space. So those are adjacent angles. There's no special formula for them because adjacent angles can be any size angles. They don't total anything. We don't know anything about them except for the fact that they touch. Then a linear pair has to be adjacent angles. So for a linear pair, they have to be touching. So 2 angles that are touching each other. So connected here at the vertex, touching each other, and together they create a straight line. So if I took this whole angle 2, so here's all of angle 2, it fills up all of this space. And then angle 1 fills up all of this space. So there's no blank space between them, and together they create that whole straight angle or that whole straight line. Okay, and we know that a straight angle or a straight line is 180 degrees. So for a linear pair, anytime we have a linear pair, we know that the 2 angles added together will equal 180. So we can use this formula, blank plus blank equals 180. So remember that linear pairs have to be touching and 2 angles. So here's a non-example of a linear pair that people often mistake for a linear pair in the beginning of learning about linear pairs. So we've got this angle here, AOC, which takes up this chunk right here. Okay, so AOC. And then we have angle BOD. So BOD is right here. And that's just this part. So there's all of this blank space in between those angles. So even though we've got a straight line here, these 2 angles don't make the straight line because we're missing this whole chunk of angle here. Okay, so there's 3 angles here that make a straight line, but remember a linear pair has to be 2. So angle addition would tell us that red plus green plus blue equals 180, but red and green together do not make a straight line. So that's a non-example of a linear pair. Final angle pair that we're going to talk about today are vertical angles. So vertical angles are 2 angles. So you see this red angle and the blue angle. They share a vertex, so they're connected by the vertex. And together they create opposite rays. So you see this angle here, whoops. So you see this angle this way and this way create a straight line. So those are opposite rays. Then you also see this one with this one is opposite rays as well because they are creating straight lines. So those two angles, 1 and 2, are called vertical angles. Now vertical angles are equal to one another. Okay, so we have this angle here is actually the identical measure as this angle here. So angle 1 and angle 2 are equal to each other. So piece equals piece. So if this is 30 degrees, then so is this. So they are exactly equal to one another. Vertical angles are across from each other. So you'll see them across from each other. And actually, we do have another set of vertical angles in here. So let me just draw that on here for you. So this right here, this angle and this angle are actually vertical angles as well. So if I labeled those maybe with a 3 and a 4. So angle 3 is actually congruent to angle 4 as well as angle 1 being congruent to angle 2. So you have two sets of vertical angles there. And then that's the formula.